Hello everyone, welcome back once again. I am Nagaraj S. Kumbargoppa, lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belagavi. In this video also, we will discuss about the introduction part of design and analysis of algorithms, and this is the last lecture from this particular unit. Here in this video, I will be covering trees, rooted trees, ordered trees, and finally sets and dictionaries. And we'll see what are trees. A tree is a connected acyclic graph. That is, a graph that has no cycles but is not necessarily connected is called a forest. A tree is nothing but it is a connected acyclic graph, and a graph that has no cycles but is not necessarily connected is called a forest. The number of edges in a tree is always one less than the number of its vertices. That is, E equal to V minus 1, determinant E equal to determinant minus 1. Then here I have one example of tree and forest. Forest is nothing but it is a collection of trees. As we have here trees and forests in generally in data structure also, in linear data structure also, that is trees, we have trees and forest. Tree is a single tree and forest is nothing but multiple or collection of trees. This is about trees. Then we have rooted trees. Rooted trees play a very important role in computer science, a much more important one than free trees do. That is, here we have one example, a free tree and transformation into a rooted tree. Free tree and transformation into a rooted tree. The tree we are transferring into the rooted tree, that indicates which is the parent tree, parent node of this particular tree is a root node of this particular tree is, which is indicated by the transformation into a rooted tree diagram. That is, this particular tree will be indicated with the help of rooted trees. That is, a free tree can be transferred into the rooted tree. That rooted tree will be containing root node, subnode, subtree, and so on, siblings and so on. That is about rooted trees. The next we have ordered trees. An ordered tree is a rooted tree in which all the children of each vertex are ordered. A binary tree can be defined as an ordered tree. Here, every vertex has no more than 2 children, and a number assigned to each parental vertex is larger and smaller than all the numbers in its left subtree and smaller than all the numbers in its right subtree. Such trees are called binary search trees. For example, here we have binary tree and binary search tree. With the help of these values, numbers of the nodes, we can identify that which node or which vertex is having left vertex, left subtree or right subtree. That is all about the ordered trees. And next we have sets and dictionaries. A set is nothing but it can be described as an unordered collection of distinct items called elements of the set. Sets can be implemented in computer applications in two ways. A data structure that implements the three operations such as searching, adding and deleting items from collection is called the dictionary. Then data structures leads to an abstract data type. That is all about sets and dictionaries. And let us summarize what we learned in this session. What are the trees and their representations? what are rooted trees and their representations, what are ordered trees and their representations, and finally what are sets and dictionaries. If you are having any doubts, please do ask your queries, and thank you very much.